Okay, so on this next one, this is geometric scenarios. This should be page 86 of your note spiral. And I'm going to move fairly rapidly through this. Not initially, but I'm going to move fairly rapidly because it becomes repetitious and I think you will get it. So the probability that any terminal is ready to transmit is 0.95. So we have a probability of transmission of 0.95, and we have the probability that it won't transmit is 1 minus 0.95, which is just plain old 0.05. How many terminals will we need to be tested until we find one that is ready to transmit? So it's like, okay, our transmission rate is 0.95. We're going to test until we find one. So we're going to test the first one, and then it didn't work, and the second, and the third one. So we're hunting for the first one. So, hey, how many do we expect to have to do that? Oh, I said the word expect. That's a good key word. So we're going to expect the expected value, and we're hunting for the first. So this is a geometric 1 over p. So in this case, it's just 1 over 0.95. And on average, we'd expect to have to check 1.0526. And this is where we'd say, in the long run, or if we did this repeatedly, or on average, we would expect to have to test 1.0526 to find one that actually works. What is the probability that the first terminal ready to transmit? So here we see this key word, first. This implies that we're working with a geometric. Ready to transmit is the first terminal tested. So this is a specific value. Because it's a specific value, it lets me know I'm working with a geometric PDF. So we have a geo PDF, and our probability of success is 0.95, and we want it to occur on the first one. That's supposed to be a 1 right there. So geometric PDF and occurring on the first one. Well, in this particular problem, we're going to have it occur on the first one, so 0.95 to the 0, to the 1, and then 0.05 to the 0. Now, some of you are going, could I have just written 0.95 on that and received full credit? Yes, you could. And I'm going to just real quickly punch that in the calculator, which is going to be second vars, geometric, PDF, 0.95, x value is 1, and we end up getting 0.95, okay? The next one, what is the probability that the first terminal ready to transmit is the third terminal tested? Once again, there's that word first. That lets me know it's a geometric. It's the third one. So this is a specific value. So this means it's a GeoPDF. So for the calculator, and by the way, the calculator work does not get you any credit. I'm just writing this down so you know what to punch in, 0.95, 3. But that gets no credit. In order to get credit, you're going to have to go ahead and show me the work, which in this case, we're going with 2 blanks, and the probability of success is 0.95, and this is to the first power, and then we have 0.3. 3 minus 1 is, or 0.05. So 3 minus 1 is 2. So 0.05 squared times 0.95 to the first. I'll rewrite that. 0.05 squared times 0.95 to the first. Second vars, geometric, PDF, 0.95. My x value happens to be 2. And we end up getting wow, I'm having a little trouble this morning. The success needed to occur on the third one is 0.002375. Please, here's one reason to do this. One reason to put the 2 in the 1 is so that you remember to use the third power. All right, make sure that, that's what tells me my x value is this plus this. All right, so please make sure you do something that makes sure you get it right. I don't care if you put to squared or to the first and have the first you don't have to have, so that's up to you, but sometimes it does help you out and it lets me know when I make a mistake like I just caught. So what is the expected number of terminals that will need to be tested until we find one not ready to transmit? So we have expected value, And we're testing until we find a failure. So since we're testing until we have a failure, that's going to be expected value is 1 over P. But we're talking about not ready to transmit. Well, ready to transmit was 0.95. Not ready to transmit is 0.05. So my P in this case is 0.05. So this is going to be 1 over 0.05, which equals to 20. So on average, or if we did this over and over and over again, we would expect to have to go to 20 different terminals in order to find one that didn't work. Might be the first one that didn't work, might be the 200th one that didn't work, but on average, we would expect it to take 20. What's the probability the first terminal not ready to transmit is the 10th? So once again, not ready. This tells me my P right here is 0.05. We have the word first. That tells me it's a geometric and the 10th terminal. So because we have a specific value, this is going to be a PDF, and most of this page is going to be a PDF. So GeoPDF, and in this case, a probability of not transmitting is 0.05, and we want to be on the 10th. So my X is 10. So that's my calculator speak. My actual work shown is going to be, well, 0.05. This is going to be to the first. And then we have 1 minus 0.05, which is 0.95. And 10 minus 1 is 9. 9 plus 1 is 10. Second vars, geometric PDF, 0.95, and I'm going to change my X value to a 10. Second vars, geometric PDF, 0.05, X value is 10. And we get 0.0315. All right, 0.0315. By the way, please get used to on probability going to 4 decimal places. All right, so for probability purposes, please make sure you're going to 4 decimal places. What's the probability the first terminal not ready to transmit is the 20th terminal tested? All right, the first terminal not ready to transmit. So once again, we have a P of 0.05, because we have the not ready, is the 20th. So this is a specific. This tells me it's a geo. Because it's specific, it's a PDF. So geo PDF 0.05, and my X in this case is 20. All right. So that's my calculator speak, which gives me no credit, but it tells me what to punch in the calculator. 0.05, that's always going to be the first because we were working to the first success. So this is a success. These are all fails. 0.95. 20 minus 1 is 19. So second vars, geometric PDF, 0.05, X value is 20. 0.01186. 0.0189. More than 4 digits is okay, but 4 digits is what we're looking for. So what's the probability that the first terminal not ready to transmit is the 30th? So once again, this is a specific value. This lets me know it's a PDF. First tells me it's a geo. So this is a geo PDF. Not ready was our 0.05. And our X value is 30. My actual work for credit is this. These are fails. This is success. This is 0.95. This is 0.05. The success is always to the power of 1. 30 minus 1 is 29. So second var is geometric PDF, 0.05, X value 30. And we get 0.00129 or 0.0113. All right, now we're going to get to change things up a little bit. what is the likelihood that the first, so this tells me we're working with a geo, terminal not ready to transmit is found before the 100th is checked. Wow. All right, so we have a number line. It could be the first one, second one, third one, all the way up to, and I always go one above, one below, and one above. So they say 100, 101. That's one below, that's one above. They said before the 100. Notice I'm circling multiple values. Because I'm circling multiple values, this means this is a CDF. So essentially, I'm doing the CDF of 1 plus the PDF of 1 plus the PDF of 2 plus the PDF of 3, all the way to the PDF of 99. And if I'm taking a test, I'm taking an L on that question because I know that I'm going to make an error or it's going to take too long. But we have a CDF function. All right, so once again, we're working with not ready, which has a probability of 0.05. And it has to be before the 100th, which means it's the 99th. So that's my calculator work. That's what I'm going to actually put into the calculator, where this is my X. So how do I show my work? Well, with the CDF, we always show our first one. All right, well, our first one is going to be 0.05 to the first power. Technically, there's a little 0.95 to the 0, but you don't have to write it unless you want to. Plus dot, dot, dot. Then we need our two blanks. This is going to be 0.05. It's always to the first. And this is going to be 0.95. And this is going to be, we have an X of 99. So 99 minus 1 is 98. So we're going to go ahead and plug this into the calculator, or plug that into the calculator. And here we go. Second vars, geometric, CDF, which is letter F. And our p-value is 0.05. Our x value in this case is 99. And we end up getting 0.9937 or 9938. Real important, you must show the 0.05, the very first one, plus dot, 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 plus the last one, which is 0.95 to the x minus 1, and then just 0.05, all right? And once again, you do not have to include the first unless you just want to. Okay, you have to have this, but you don't have to have to the first power. Okay, 2% of cars have a defective seatbelt. How many cars would you expect to have to check to find one with a defective seatbelt? Well, first off, we have expect. So we know we're working with an expected value. We know we have a probability of 0.02. And you said, okay, so we're going out there and we're checking cars. And we check the first car, then the second car, and the third car. And we're looking for the first one. Oh, there is that word. This is what we're doing. So 1 over P is 1 over 0.02, which is 50. So on average, I'd have to actually go out and check 50 cars in the parking lot to find one with the defective seatbelt. By the way, that 2% is a fake number. The car company would be sued out of business if that were really true. Okay, so what is the probability the first defective seatbelt is the 50th seatbelt checked? Okay, so in this case, we have first. This lets me know I'm working with a geo, but it has to occur on a specific trial. So this makes it a PDF. So this is going to be a geo PDF. And in this case, the probability is 0.02. And it has to happen on the 50th. All right, so geo PDF 0.0250, this is my X value. Work shown, because it's a PDF, I only need the two blanks. All right, this one is 0.02 raised to the first power. This is 0.98 raised to the 49, because 50 minus 1 is 49. I'll plug this into the calculator. .02, X is 50, and we get 0. What did I do wrong? Second vars, geometric PDF, 0.02, X is 50, and we get 0.0074, all right? So fairly small percentage, and by the way, as you notice, we're getting close to 0, which is why we need these 4 decimal places, all right? So make sure you're keeping 4 decimal places. The next one, what's the probability the first, so this lets me know we're working with a geo, is found prior to the 51st one. So that means it could be the first one, the second one, third one, and I'll always go up to one below and then one above. All right, prior to the 51st means any one of these. So essentially I'm doing a PDF of 1, 2, 3, all the way up to 50, which means I'm working with a geometric CDF because we're combining. All right, so I'm going to rewrite that, Geo CDF, because it's the sum of all the PDFs. Our probability is 0.02, and then our X value in this case is 50 for the calculator, because we're going to go all the way up to the 50th one. So once again, I'm really doing the PDF of 1, the PDF of 2, all the way to the PDF of 50. So I have to show my work, which means I have to do the first one, and then I have to do the last one. Okay, the last one is 0.02. This is 0.98. This is going to be 50 minus 1 is 49. 49. And this is a 1. This is also going to be 0.02. This is to the 0, and this is to the 1. Do not have to include that. You could just start here. It's up to you. All right, but this is what your work is going to look like. So if you have this material, you're going to get full credit for your work. Second vars, geometric CDF, probability is 0.02, X is 50. And we end up getting 0.6358. So that basically means if I were out in a parking lot and it had a 2% defective rate, that somewhere the chance that it would be the first car, the second car, the third car, if I add up all those chances all the way to 50, I'm going to get to 0.6358, all right? So there's a 63% chance that somewhere among those 50 cars, I will find the first defective seatbelt.